Following statements are equivalent. Integral f dot dr equal to 0 around every closed loop in D, and the second one is the field capital F is conservative on D, conservative on D. We have to prove these two statements are equivalent. For that, we need 1 and 2 are equivalent. First of all, we will assume this one and we will prove this 2. So assume 1. 1 means integral f dot dr equal to 0 around every closed loop in D. Next, we have to prove that f is conservative on D. F is conservative. In order to show that f is conservative, we have to show that to prove f is conservative, integral f dot dr is path independent. So in order to prove that this is path independent, we have to pick, suppose this is a domain D, this is A, this is B, this is the path C1 and this is the path C2, right? So, and this is the path C2, and choose this C1 and C2 as C1, this is a domain, and to choose any 2 points A and B, consider 2 paths C1 and C2 here, and this from C1 to C2, C1 minus C2, C1 this is minus C2, C2 is a closed loop in D, right? And we know that this line integral over C1 minus C2 0, because this is a closed loop. By our assumption this is equal to 0. Therefore integral over C1 f dr plus integral over minus C2 f dot dr is equal to 0. So integral over C1 f dot dr minus integral over C2 f dot dr equal to 0, which implies integral over C1 f dot dr equal to integral over C2 f dot dr, which means what? Which means that that's equal to 0 for any. This is equal means the line. This is true for any AB in D, right? So and any AB in D and any C1 and C2. So this is true for any path in D. So integral f dot dr is path f is, right? We have to prove the converse. First assume that f is conservative. We have to show that this is around any closed loop is equal to 0. Consider a closed loop. Previous case, this is total is C, right? C equal to here C1 minus C2, and we have consider a domain D. This is a domain D, path A, this is B, okay, this is C1, and this is equal to this is C1, this is C2 actually, right? The C1 plus C2 equal to C actually. This is the total path. So integral over C f dot dr equal to integral over C1 plus C2 f dot dr. F dot dr plus integral over c to f dot dr. Path independent, so integral a to b f dot dr. This is c2 means minus integral a to b f dot dr, which is equal to 0. Okay. Therefore, integral over c f dot dr equal to 0 for any closed path c in D. Let f is equal to mi plus mj plus pk. F is conservative if and only dou p by dou y equal to dou n by dou z. That is m n p x y z. Dou n by dou y equal to dou n by dou x, and also dou x equal to dou n by dou z. How can we memorize this? Equal to dou n by dou y equal to dou n by dou x. Next is dou n by dou z equal to dou p by dou y. And next to consider this m and x here. Dou p by dou x equal to dou n by dou z. Okay, this we are going to determine. Next we have to solve the problem. As said, here m equal to e raised to x into cos y plus yz. N equal to xz minus e raised to x sin y. P equal to xy plus z. First we have to check whether this is conservative or not. For that we have to find dou m by, this is the formula, m n p m x y z x, dou m by dou y, which is equal to minus e raised to x sin y plus z. Dou m by dou x is equal to z minus e raised to x sin y. They are equal. Next is dou n by dou z. Dou z is equal to x. Dou p by dou y, which is equal to x. So they are equal. Okay. Next is dou p by dou x. Dou p by dou x, which is equal to y. And dou m by dou z equal. So f is conservative. So f is conservative field. So we can find out a scalar potential. F is equal to del f. Correspondingly, we have to find out a del f. Right? Del f is equal to actually dou f by dou x into y plus dou f into k. From this, dou f by dou x is equal to e raised to x into cos y plus yz. Dou f by dou y equal to xz minus e raised to x into sin y. Dou f by dou z equal to dou f by dou z is equal to what? Xy plus z. This is first equation, second equation, and the third equation. What we have to do? First of all, we have to do is we have to integrate the first equation, that is dou f by dou x. First integrate. First integrate 1 with respect to x. So f of x y z is equal to integral e raised to x cos y dx cos y plus yz into dx, which is equal to e raised to x cos y plus xyz plus a constant. This constant means actually that is a function of next variable. Here integrating with respect to x. So if it is suppose this is y square, then when we are calculating dou f by dou x, this term will be 0. So when we are integrating with respect to x, the other two variable will be treated as the constant. So this is plus a constant which is represented as g of yz. Suppose this is yz, and differentiating with respect to x, then that term will be 0. So constant can be a function of y or z or a constant itself. So we are writing g of yz, right? This is equation 4. What will be the next one? Will be the next procedure. Next, to calculate dou f by dou y from this. That's equal to minus e raised to x sin y plus xz. 2 from 2, this is equal to xz minus e raised to x sin y. Okay. By equating these two, we will get dou g by dou y equal to 0, which implies g is a constant and g is a function of z alone. G is a function of z alone. So this is a function of z alone. This is h of z. Okay. So I can write this as our fourth equation can be modified as this is a function of h of z itself actually. G equal to h of z. So I can modify this 4 as from 4 f of xyz equal to e raised to x cos y plus xyz plus h of z. This is equation number 5. This is our new f. Okay. From this, evaluate dou f by dou z. This is equal to xy plus dou h by dou z. From equation 3, we can see that that's equal to xy plus z. By equating these two, we will get dou h by dou z equal to z. So what will be h of z? That's equal to z square by 2 plus a constant c. Therefore, f of xyz equal to what? E raised to x cos y plus xyz plus z square by 2 plus c. This is equation f here.